welcome back to the channel. My name is Cornelius. So in the last video we talked about data types in Python, and today we are taking it a step further by talking about operators. So operators are like symbols that define the kind of operation we can perform on data types in Python. But before we go ahead, I want to address an issue in the last video on data types. So in that last video, during the collection discussions, I was talking about tuples, and I make this mistake with constants here. So the real syntax should be parentheses, not square brackets. All right, this is the real syntax for tuple. And also you can add as many items as you want, including those of different data types. You could also say hi, and then you can print it out with the print constants. And when we run it now, you should see 3.142 true and high. So that's it. Now back to today's video, we are going to be talking about operators. So there are different kinds of operators in Python. We have the arithmetic, comparison, assignment, logical, bitwise, membership, and identity operators. So starting from arithmetic operators are operators that we use to perform basic math operations. So let's create two variables. I'll say a should be 6 and b is 3 or 4. So I'll do print a plus b, and when we run it, you get 10. So I can also do print a minus b, so you get 2. All right, you can do a multiply by b for multiplication, and we get 24. Then there is also division operation, a multiply by b, a divide by b, sorry. So when we do that, we get 1.5. So we get a decimal point. Now, every division in Python always has a decimal point. So even if I do something like this, if I change it to 3 and we check it, you see 2.0. There is always a decimal point. Now, to make sure we avoid this, if you want to, it's not a bad thing to have decimal points, but if you don't like it, you can always do a floor division. Now, a floor division will return the nearest smallest whole number. So when we run it now, you get 1 instead of 1.5. Then the other operation we can perform is called modulus operation. So the modulus simply returns the remainder. So when I do mod, you get 2. So we can get 4 in 6, remainder 2. So that's what we get with modulus. Then the last one we're going to talk about under arithmetic is the exponentiation. So basically a to the power of b, and when we run it, you get 1296. So that's that's 6 times 6 times 6 times 6, or simply 6 to the power of 4. All right. So to comparison operators are like operators that we use to compare two values, and the output is always Boolean, so true or false. I'll remove this one so that we can I'll comment this out so we can use I'll comment it out so that what we are writing will be clean. Then I'll say a should be equal to 10, b will be equal to 20. Now we'll print a equals b. So we are saying we are using the equality operator, equality comparison operator, to check if the value a is holding is equal to the value b is holding. And when you run it, we get false. It's not equal to it. So we can also do a not equal to b, and of course the answer will be true because a is not equal to b. And we can try a, should I say, greater than b, and of course the answer will be false because a is not greater than b. We can also do A less than B. The answer is true. A is indeed less than B. Then we can also give it a choice. Is A less than or equal to B? We'll talk about or in the logical operation. But for now, the or operator returns true if either condition is true. So both does not need to be true, just one has to be true. So in this case, we are saying is A less than or equal to B, and A is indeed less than B, even though it's not equal to. So we get true. Then the reverse, we can also try it. Is A greater than or equal to B? Now in this case, A is not equal to B, neither is A greater than B. So in this case, the or operation will be false. So A is not greater than or equal to B. And this is very useful when we are doing conditionals later, like if and else statements. So the third kind of operators we're going to talk about is the assignment operators. So we can say, let me also comment this out. Right. I'll comment this out. And we also create a variable. I'll say A should be equal to 4 and B is equal to 5. Excuse me. So they'll print sorry, this should not be print. I'll say A should be plus equal to 1. And what does this mean? We are setting the value of A, we're incrementing it by 1. So now when we print A, you get 5. All right, you get 5 because we take the value of A and we increment it by 1. We can also do multiplication and say print B multiplied by or equal to 2. Sorry, I should not do it here. So we do B multiply equal to 2. So in this case, it will be 5. The value of B, which is initially 5, multiplied by 2. So we get 10. You can also do division. You say B divided by equal to 2. Why not? So now we'll print B. So we get 5.0. Remember, the division, we always return a decimal point. So since B has been multiplied and the value of B is now 10, so when we do B divided by equal to 2, it divides it back to 5, but with a decimal point. And you can also perform the floor operation. We can do B, let's go with A this time around. So say A floor division equal to 2. And then we'll print A. What do you expect to see? We see 2 because floor division will print the nearest smallest whole number. So we can also perform for power, right? So we'll say A should be exponentiation equal to 3. And now we'll print that. So you get 8 because A is 2, so exponentiation, that's 2 times 2 times 2 in 3 places. So that's all for the assignment operation, and I'll also comment it out. I'll comment it out so that what we are printing in the terminal will be easy to see. So onto logical operators. So logical operators simply returns true or false. All right. So let me say we have two variables. A is equal to true. Then B is equal to false. All right. So we print A and B. What do you get? You get false. Why? For logical AND, the AND will return true only if both conditions are true. But if one is false, it will always be false. So if I go ahead now and change this to true, then only then will it return true. But if it goes back to false, then the output will be false. So the other logical operator we can talk about is the OR operator. So we'll do print A or B. And like I mentioned earlier, the OR operator needs only one of the conditions to be true. So if one is true, OR operator returns true. So it only returns false if both are false. So in this case, the OR operator, when I run it, OR returns true. So OR will only be false if both are false. So if I change A to false, then OR will be false. But other than that, as long as one is true, the OR operator always returns true. Then we can also do the NOT operator. Now the NOT operator is used on only one operand, and it negates the value of that operand. In other words, if the operand is true, it flips it to false. If it is false, it flips it to true. So we'll say print not A. So we do not A. So since A is true, the not will flip it to false. If we also do not B, remember B is false, the not operator flips it to true. So that's simply what the not operator does. So that's all for logical operators, and we are moving to bitwise. Now bitwise operator is a little bit tricky. You need to understand binary, but I'll try my best to break it down as much as possible. So say we have two variables, right? I'll say A is equal to 4 and B is equal to 5. So bitwise operation happens on the bit level, on the binary level. Remember, our computers do not understand what we are writing in Python. So there is a special program called the interpreter that takes what you write in a high-level language like Python or JavaScript, or a compiler for languages like C++ and C or Java. So it compiles the code we've written in a high-level language and translates it into something that the computer can understand. And computers only understand machine code, which is binary. So something like zeros and ones, all right? Zeros and one. So in this case, with bitwise operation, whatever we do with bitwise operation happens on the bits level. So we are manipulating bits. So when we do A equals 4, on the bit level, we get 100. The binary representation of 4 is 100. So I'm using a 3-bit binary. All right. So for 5, I think it's 101. Yeah. Remember, you can represent it with as many bits as you want. You could use 4 or 8. I just choose to use 3 since the numbers we are using is not too big. So I'll do print A and B. So now in this case, what are we trying to achieve? We are using the bitwise AND operator on A and B, Now, the bitwise AND operator, just like logical operator, returns true if both conditions are true. And in binary, we use 1 to represent true and 0 to represent false. So you see the first bits of 4 and 1 are both true. So we get 1. The second bit of 4 and 5 are 0, which is false. So we get 0. Now, the last bit of 4. Now, the last bit of any binary is called the least significant bit. So the least significant bit for 4 is 0. The least significant bit of 5 is 1. And the AND operator will only return true if both are true. So in this case, it returns false. So bitwise AND operator on 4 and 5 will return 4. So when I run this program now, we expect to see 4. Then I can also perform the OR, bitwise OR operation. I'd say A OR. So you just use a single slash. So we say A or B. Now what happens on the bit level? So in this case, the OR operator returns true if either is true or if both are true. So the first bit in 4 is 1, 5 is also 1, so we get 1. The second, they are both 0, so we get 0. Then for the last, 4 is 0, 5 is 1. So since the OR will return true and 1 is true, so we simply get 1 because one of both operand is true. So now when we run it, Remember, the binary for 5 is 101, so we should expect to see 5. Then we can also perform the exclusive OR. Now, the exclusive OR will only return true if one is true and the other is false. But in cases where both are either true or false, the XOR operator, exclusive OR operator, returns false. So we do print A or, yeah, I think this should be the operator. I can't really remember. So for the exclusive OR, it flips it. Since both are true, 1 and 1, we get 0. Now for their second bits, both are 0, we also get 0. Then for the last, 1 is true, 1 is false, then we get 1. So in this case, 001 is the binary representation of 1. So when we print it, we should get 1. Then for the other one, the NOT operator. Now the NOT operator is a little bit tricky, and I don't want to go too deep into binary because this is more of a beginner's video. So the NOT operator, sorry about that, is performed on a single operand. And what you get at the end of the day is will be, let me just give you what you get. So what you get at the end of the day will be x, it will be minus x plus 1. All right, in our case, x will be the value of b. So when we run it, we should be able to see minus 6. All right, so that is the bitwise NOT operator. Then last but not the least, let's talk about the left shift and right shift. And these two are also a little bit tricky. I don't think I should even do it in this video, but let's try it anyway. So if we want to left shift for B, or let's do B. Let's left shift for B. Now, using a 4-bit binary, if we use a 4-bit binary, B will be 0101. All right, so we simply, for a 4-bit, we simply add a 0 here. So for the 4-bit binary representation of 5 is 0101. So when we shift to the left, we do this, and the space on this side is filled with a 0. All right, so the space to this side is filled with a 0. Where we shift from, we represent the empty space left with a 0. So now when we print the left shift of B, we should get 10. All right, so the opposite is also the right shift. So I'll do B, print B right shift, right shift by 1, excuse me. So if we right shift by 1, also using a 4-bit binary representation, which is 0101, if we shift by 1, here, all right, we'll put the 0 at the back here. And this is the binary representation of 2. So when we run the program, B right shift will be 2. So bitwise operation happens on the binary level or on the bits level. So it's very useful when we are doing systems programming and so many other things. In fact, we can just try it a little bit. So say we want to write a program that checks if a number is an odd number. All right, one thing you'll notice is that all the numbers that are odd, like 5 and 1 in our outputs, their least significant bit is 1. So say any number, to check if a number is odd number, we say if the number you are talking about, if a and 1, sorry, I've forgotten I'm not writing C++. So if a and 1, we should print a is odd. Right, so when we run the program, we get if a and 1, print a is odd. Sorry, I should put this inside a function, I think. If a and 1, print a is odd. Yeah. Okay, is A still odd? Or have we flipped A? Or should I use B? Yeah, 4 is odd. Good. So A is already 1. We flipped A to 1 here. So we are using B here. So we are using B here. So if B is odd, print B is odd. So print the value of B is odd. That's simply what we're doing. So now onto membership operator. For the membership operator, we simply check if a value is present in a sequence of string or a list. All right. So let's use a list, for example. So I'll say for list, let us simply go back to the previous video and I'll copy the list from there. Command C and bring it here. Command V. So we'll say print 72 in scores. So we are saying check if 72 is in the list, and the output of membership operation will be a boolean. So in this case, since 72 is in the list, we get true. All right. So if we come down here and we say print 100 in scores, so we expect to get false because there is no 100 inside the list. So we can also check, say, if J in John, print J in John. When we run this, we should also get true because there is J in John. Then lastly, we want to do the identity operation. So identity operation simply checks if two values are equal to each other. So let me create a list. I'll say, let me create another list. Sorry, I should come under identity. So I'll say A is equal to 1, 2, 3. Then we also say B will be equal to 1, 2, 3. Now we'll print A is B. And yes, A is B. Let me comment out all this so that we can see the output of what we're doing. So I'll comment out all of this. So when we run it, we're saying is A is B. A is B will be false. Sorry, A is B will be false. But when we do print A equals B, right, this will be true. So the reason why this is false is because A and B are at different locations in memory. They are not at the same location. But this one, we are saying that is the value that A is holding equal to the value that B is holding, which is true. They both hold 3 elements in each of the lists. So that's all for this video. And thank you so much for watching. Please, this is a new YouTube channel, and if the content I'm creating, if you find it useful, please make sure to like the video and subscribe. It helps me a lot. Thanks for watching, and I'll see you in the next video.